In a presentation, Jelinek claimed it was whenever I fire a linguist our system performance improves, and it came from a talk applying information theoretic methods, evaluation of grammar quality workshop on evaluation of NLP systems, Wayne PA, December 1988. Frederick Jelinek was a highly influential Czech-American researcher known for his foundational contributions to information theory, automatic speech recognition, and natural language processing. He is widely credited with pioneering the use of statistical methods in speech and language processing, a paradigm shift that revolutionized the field and forms the basis of modern speech recognition and machine translation technologies. Jelinek led significant research efforts at IBM and later at Johns Hopkins University, where he continued to advance data-driven approaches and fostered collaboration within the research community through initiatives like summer workshops. His work laid the groundwork for how computers understand, transcribe, and translate human language, making him a central figure in the development of today's ubiquitous speech-enabled technologies. Frederick Jelinek was born as Bedřich Jelinek in Kladno, Czechoslovakia, now the Czech Republic, on November 18, 1932. His early life was significantly impacted by World War II and the Nazi occupation. Due to anti-Jewish decrees, he was barred from formal schooling after second grade, receiving education in makeshift, privately organized classes. His father, a Jewish dentist, died in the Theresienstadt concentration camp in 1945, though his mother, who had converted to Judaism and had Swiss origins, and the children, considered half-Jewish, were able to avoid concentration camps. After the war, he entered gymnasium but struggled due to the years of missed formal education. In 1949, his family emigrated to the United States, settling in New York City. Although he initially aspired to be a lawyer, he pursued engineering studies in evening classes at the City College of New York. With financial assistance from the National Committee for a Free Europe, he then attended the Massachusetts Institute of Technology (MIT), where he earned his Bachelor of Science, Master of Science, and eventually a PhD in Information Theory in 1962. His doctoral dissertation was titled Coding for Discrete Memoryless Two-Way Channels. He began his academic career as an instructor at MIT, followed by a brief lectureship at Harvard University, before becoming a professor of electrical engineering at Cornell University from 1962 to 1974. Here's a paragraph summarizing each of Frederick Jelinek's notable works, as requested. Jelinek, Frederick 1968. Probabilistic Information Theory, Discrete and Memoryless Models. In 1968, Frederick Jelinek published his foundational textbook, Probabilistic Information Theory, Discrete and Memoryless Models. This comprehensive volume served as a critical resource for students and researchers in the burgeoning field of information theory. It systematically laid out the theoretical underpinnings of discrete and memoryless communication channels, covering essential concepts such as entropy, channel capacity, and coding theorems. The book's rigorous mathematical treatment and clear exposition made it an indispensable reference, solidifying Jelinek's early academic contributions to the theoretical aspects of communication systems. Jelinek, Frederick 1969. Fast Sequential Decoding Algorithm Using a Stack. Jelinek's 1969 paper, Fast Sequential Decoding Algorithm Using a Stack, introduced a significant advancement in decoding techniques for convolutional codes. This work proposed a novel algorithm that utilized a stack data structure to efficiently search for the most likely transmitted sequence, offering a more computationally tractable approach compared to existing methods at the time. This innovation was crucial for enabling more practical and faster decoding of noisy communication signals, demonstrating Jelinek's early focus on efficient algorithmic solutions for problems in information transmission. Jelinek, Frederick 1969. Tree encoding of memoryless time-discrete sources with a fidelity criterion. Also in 1969, Jelinek's paper, Tree encoding of memoryless time-discrete sources with a fidelity criterion, addressed the problem of source coding with a focus on data compression while maintaining a certain level of fidelity. The paper explored the concept of tree encoding, where a source's output is mapped to a code word by traversing a tree structure, aiming to minimize distortion given a rate constraint. This work was recognized with a Best Paper Award in 1971, highlighting its significant contribution to the understanding and development of efficient data compression techniques, particularly in the context of information theory. Ball, Lalit R. Jelinek, Frederick Jelinek, Joseph Raviv 1974. Optimal decoding of linear codes for minimizing symbol error rate. The 1974 paper, co-authored by Jelinek with Lalit R. Ball, Jelinek, and Joseph Raviv, titled Optimal Decoding of Linear Codes for Minimizing Symbol Error Rate, presented a seminal algorithm that became known as the Ball-Koch-Jelinek-Raviv BCJR algorithm. This groundbreaking work provided an efficient dynamic programming algorithm for maximum a posteriori map decoding of linear block codes and later extended to convolutional codes. The BCJR algorithm was a pivotal development, offering an optimal way to decode codes by minimizing the probability of individual symbol errors, and it remains a fundamental technique in various areas of signal processing, including turbo codes and hidden Markov models, earning it the Information Theory Society Golden Jubilee Paper Award. Jelinek, Frederick 1976. Continuous Speech Recognition by Statistical Methods. In his influential 1976 paper, Continuous Speech Recognition by Statistical Methods, Frederick Jelinek laid out a compelling argument for the statistical approach to speech recognition, a paradigm shift that moved away from purely linguistic or rule-based methods. This work, stemming from his research at IBM, highlighted the effectiveness of using probabilistic models, particularly hidden Markov models (HMS), to model the acoustic and linguistic variability in continuous speech. The paper articulated the core principles of the statistical framework, including acoustic modeling, language modeling, and decoding, setting the stage for the highly successful data-driven approach that would dominate the field for decades and profoundly impact the development of modern speech recognition systems. Brown, P. J. Koch, S. Della Pietra, V. Della Pietra, F. Jelinek, R. Mercer, and P. Russin 1988. A Statistical Approach to Language Translation. The 1988 paper, co-authored by Jelinek and his colleagues including Peter Brown and Robert Mercer, A Statistical Approach to Language Translation, marked a pivotal moment in the history of machine translation. This work presented the pioneering statistical machine translation (SMT) approach developed at IBM, which relied on probabilistic models learned directly from large parallel corpora, rather than handcrafted linguistic rules. By treating translation as a decoding problem where the most likely target sentence is found given a source sentence and a statistical model, this paper introduced concepts like translation models and language models that became cornerstones of SMT, fundamentally altering the trajectory of machine translation research. Jelinek, Frederick 1990. Self-organized language modeling for speech recognition. Frederick Jelinek's 1990 contribution, Self-Organized Language Modeling for Speech Recognition, delved into the crucial aspect of language modeling within statistical speech recognition systems. This work explored methods for automatically learning and adapting language models from large text corpora, moving beyond simpler n-gram models to more sophisticated approaches that could better capture the statistical regularities of human language. By focusing on how language models could be self-organized or learned with minimal human intervention, This paper significantly contributed to improving the accuracy and robustness of large vocabulary continuous speech recognition systems. Jelinek, Frederick, John D. Lafferty and Robert L. Mercer, 1990 Basic Methods of Probabilistic Context-Free Grammars. In their 1990 technical report, Jelinek, along with John D. Lafferty and Robert L. Mercer, outlined basic methods of probabilistic context-free grammars (PCFGs). This work explored the application of PCFGs to natural language processing, providing a formal framework for statistically modeling the syntactic structure of sentences. By assigning probabilities to grammar rules, PCFGs allowed for the computation of the likelihood of different parse trees, offering a probabilistic approach to parsing that was essential for tasks like speech recognition and language understanding, and later became a fundamental tool in computational linguistics. Jelinek, Frederick 1997. Statistical Methods for Speech Recognition. Frederick Jelinek's 1997 book, Statistical Methods for Speech Recognition, stands as a definitive and highly influential textbook that systematically encapsulated the statistical paradigm he championed for speech recognition. This book provided a comprehensive and accessible treatment of the core concepts, including hidden Markov models, language modeling, acoustic modeling, and decoding algorithms, which are essential for building practical speech recognition systems. It became an indispensable resource for students and practitioners, serving as a canonical text that formalized the data-driven approach and cemented its dominance in the field, making complex statistical methods understandable to a wide audience. Chalbaugh, Cyprian, Frederick Jelinek 2000. Structured Language Modeling. In their 2000 paper, Structured Language Modeling, Cyprian Chalbaugh and Frederick Jelinek introduced a novel approach to language modeling that went beyond traditional n-grams by incorporating syntactic and semantic information. This work proposed a method where the probability of a word was conditioned not only on preceding words but also on aspects of the sentence's parse structure or other higher-level linguistic features. This structured approach aimed to capture longer-range dependencies and richer linguistic context, leading to more accurate language models for speech recognition and natural language processing tasks, and earning them a Best Paper award in 2002. Su, Peng, Ahmed Imami and Frederick Jelinek 2003. Training Connectionist Models for the Structured Language Model. The 2003 paper by Peng Su, Ahmed Imami, and Frederick Jelinek, Training Connectionist Models for the Structured Language Model, built upon the concept of structured language modeling by exploring the use of neural networks, or connectionist models, for its implementation. This work focused on the practical aspects of training these complex models, addressing challenges in optimizing their parameters to effectively integrate structural information for improved language modeling performance. Frederick Jelinek passed away on September 14, 2010, in Baltimore, Maryland, at the age of 77. His death marked the end of an era for the fields of speech recognition and natural language processing, where his statistical methods had become the dominant paradigm. He leaves behind an immense legacy that continues to influence modern AI and machine learning advancements in language technologies. It is generally believed that scientific talent reveals itself in early youth. This was certainly not my case. I somehow slid into my scientific profession. My mother wished for me to become a physician, just like my father. I myself wanted to be a lawyer, defender of the unjustly accused. But my career is the result of political circumstances, academic possibilities, and lucky accidents. Talking about his life in a 2001 speech. References: Jelinek, Frederick 1997. Statistical Methods for Speech Recognition. Cambridge, Massachusetts MIT Press. PV ISBN 0-262-10066-5. Lower, Steve September 24, 2010. Frederick Jelinek, who gave machines the key to human speech, dies at 77. New York Times. PB 10. Retrieved December 16, 2010. Jelinek, Frederick November 22, 2001. How I Got Here Speech. Prague. Archived from the original on March 16, 2008. Retrieved December 17, 2010. Honoris Causa Degree Acceptance Speech. Jelinek June 13, 2006. Curriculum Vitae. Archived from the original on September 3, 2006. Retrieved December 17, 2010. Jelinek, Fred December 2009. The Dawn of Statistical ASR and MT. Computational Linguistics. 35 483-494. doi 10.1162:2009.35.4.35401. S2 SID 148-6422. Hers Henson, Roberta December 31, 1989. Czech couple keep eye on homeland. New York Times. Retrieved December 17, 2010. Willoughby, Ian June 9, 2008. Milena Jelinek, member of Golden Generation of Czech filmmakers now teaching screenwriting at Columbia. One-on-One. Radio Prague. Retrieved February 1, 2014. Jurovsky, Daniel, James H. Martin 2009. Speech and Language Processing, An Introduction to Natural Language Processing, Computational Linguistics, and Speech Recognition. Prentice Hall Series in Artificial Intelligence 2nd ed. Upper Saddle, New Jersey, Prentice Hall. P83. ISBN 978-0-13-187321-6. Palmer, Martha, Tim Finan 1990. Report on the Workshop on the Evaluation of Natural Language Processing Systems PDF. Computational Linguistics. 16-1, 171-185. Moore, Roger K. 2005. Results from a survey of attendees at ASRU 1997 and 2003 PDF. Interspeech 2005. Lisbon, September 4-8, 2005. Archived from the original PDF on July 20, 2011. Jelinek, Frederick February 1, 2005. Some of my best friends are linguists. Language Resources and Evaluation. 39-1, 25-34. doi 10.1007S10579005-2693-4. ISSN 1574-0218.